To graph number 1, we first need to make it look like y equals mx plus b. So I would subtract 2x on both sides. That will give me negative 3y equals negative 2x plus 1. Then I have to divide everything by negative 3 to get y equals 2/3 x minus 1/3. How many of you are thinking right now, seriously, Gilmore, you're gonna make us have a y-intercept of negative 1/3? Okay, now next I need you to appreciate the irony. Notice it says in italic, accuracy is very important. Okay, so keep that in your mind. Accuracy is very important. All right, so negative 1/3 is about here-ish. Yeah, ironic. For a slope of 2/3, we'd go up 2 full units over 3 units. That would be like there-ish. Yeah, I said accuracy. Just trust me. Just trust me. Be as accurate with your placement-ish as possible. Yeah, accurate and ish don't usually go together very well, but we're going to make it work. It is important that you connect your dots with as straight of a line as possible. So if you have a straight edge to use, you really want to use a straight edge. Our other equation should be much, much easier to get into y equals mx plus b. Subtract x on both sides, y equals negative x plus 3. Let's put that one on the graph. Okay. Now, the point of the graphing method is not simply to make a beautiful picture, although this is a very beautiful picture. The point of the graphing method is to find the ordered pair where the two graphs meet. So we need to look for that point where those graphs meet. What are the coordinates of that point? 2, 1. It is. It's 2, 1. I promise it's 2, 1. Okay, now question. Do you want to do this by hand every time? No, there's this thing called a graphing calculator, and apparently it will graph lines for us. So we're going to use this graphing calculator to tell us where these graphs are. Now, you do still have to do a little bit of work because you still have to get the equations into y equals mx plus b. So over here, we would subtract 3x on both sides. That would give us 2y equals negative 3x plus 4. And the other equation, if we subtract x on both sides, we'd have negative y equals negative x plus 4. Do we want negative y? No. So divide everything by negative 1 to get y equals positive x minus 4. That's the second one that we're going to put in the calculator. Okay? So let me move this a little bit so we can see. All right. So to enter negative 3/2 in the calculator, I strongly suggest parentheses. Make sure you use your negative button, not your minus button. Your minus button will create all sorts of errors. You want to use the negative button. Negative 3 divided by 2. Close your parentheses. That's the fraction negative 3/2. Remember, x is the button right next to your green alpha button. And x minus 4. Once you have the two equations in your graph or in your calculator, how do you actually see the graph? Press graph. As it's drawing these in, most of the calculators in my room are already set so that you can see the gray grid lines on the graph. If you have your own calculator and it's not set that way, or if your calculator isn't set that way for some reason, let me know. I can help you. Or, watch up here for a second. Right above the zoom button, it says format. That's formatting the graph. So if you push second format, these are all of the settings for the graph, for how your graph looks. This is the format of your graph. So notice on the third line, it says grid off, grid dot, or grid line. I have grid line selected. So you can change that setting. You can even change the color of your grid lines. Light gray is usually the best one. So if you're ever wanting your graph to look different, go into second zoom and that will give you the format options that you can have. All right, so when I look at this graph, the problem I'm noticing is that this intersection is not at a whole number. So wouldn't it be nice if the calculator could tell us exactly where these two lines meet? Yeah, it can. It can. You want the graph to calculate the intersection of these lines. So right above the trace button, what does it say? Calc. So second trace button. Which one do you think we want to pick? Intersect. So number 5, intersect. At this point, your calculator acts like a needy 2-year-old. So it's saying, hey, is this blue one? Is this the first line you want me to consider? Yes. The way to tell your calculator yes is to hit enter. And then it says, hey, is this red one the second line that you want me to consider? Yes. Hit enter. And then it's going to say, okay, do you want me to guess? Yes. Hit enter again. So it's kind of annoying. You have to hit enter 3 times, but it's second trace. That gets you into the calculate menu. And then number 5, intersect, and then enter, enter, enter. And then on the screen, it tells you that these two lines intersect at the point 2.4, negative 1.6. So the solution for this system is the ordered pair, 2.4, negative 1.6. Isn't that kind of amazingly awesome? Yes. Okay, I want you to get started on number 3 and 4. Get them into y equals mx plus b so that you could enter them into your graphing calculator, and then we'll talk about them in about 2 minutes. So get started on 3 and 4. Okay, as you look over my work, you might be thinking, Mrs. Gilmore, that red equation, you totally can reduce that fraction. Yeah, I know, but let's say you didn't realize that you could reduce that fraction. If you were to enter those two equations, y equals 3/2 x minus 3 and y equals 6/4 x minus 3, if you didn't know that you could reduce, you could put both of those in your calculator and your calculator would still plug away like normal. And it would show you, first it would graph the blue line, then it would graph the red line, and what would happen with the red line? It'd be right on top of the blue line because 6/4 is the same as 3/2. So both of these equations have the same slope. They also both have the same y-intercept. So these two are the same line, and that means infinitely many solutions. So as you're getting these ready to graph, you might notice, wait a minute, these are the same line. This is going to be many solutions. Number 4, do you notice anything interesting about number 4? Same slope. They both have a slope of 3/2, but they have different y-intercepts. That means they are going to be parallel lines. Do parallel lines ever cross or meet? No, so there are no solutions. If you happened to get that on your graph, like plug it into the graphing calculator, you'd see those two lines never ever meeting and you'd know that it was no solutions.